Hello everyone, welcome to the third video of your architecture in action. Here we're going to discuss about the catalyst optimizers. Okay, so let's take an example of the restaurant. Let's take an example of your restaurant. So let's say if you want to eat something like what do you say? Let's say if you want to grab a coffee. So you'll go to a restaurant. So you'll go to the nearest restaurant, and in the nearest restaurant you will going to check that restaurant. I mean, if you check the menu. Okay, so you'll check the menu and you will figure it out whether that coffee this restaurant served that coffee or not. Okay, if you don't find, then you'll go to the nearest restaurant, obviously, to grab that coffee, right? So this is your unresolved logical plan, um, because you don't know whether your coffee will be there in that restaurant or serve that restaurant or not. Okay, then you go to a restaurant and you check the menu, and in that menu you ask the order. Then you ask the waiter whether you will get that coffee or not, whether this restaurant serve the coffee or not. Then he says, okay, yeah, we have the coffee, but you have to wait for some minute, some time. So this become your resolved logical plan. Otherwise he will say, okay, this otherwise he will say the coffee, we don't serve the coffee, and the person will go to the next restaurant, nearby restaurant. Okay, because that coffee doesn't exist. Similarly in the code, if the tables are not found, okay, if the tables are not found, so it will throw the error that this table does not exist, right? So this is what first is the unresolved logical plan. So the table can exist or not exist. If it exists, it will check in the catalog. Okay, catalog, okay, this table exists, then it will create a resolved logical plan. Let's say your coffee is available in the team in the restaurant. Okay, so the waiter took the request from the customer to the chef, and then he told them that he gave the 5 to 10 minutes waiting time to the customer, and he'll check with the chef whether he will be able to make it in that particular time or not, 5 or 10 minutes or not, right? So now the chef will check whether he will able to make it or not in 5 to 10 minutes, because he has to check out the raw materials to make that coffee. It may exist that the um, let's say if that particular thing to make the coffee does not exist, let's say he don't have the sugar. So what are the alternative he can have? The chef, that call will take by the chef, whether he can use the stevia or some other sugar free, or maybe something to make it sweet. Okay, so that's what we call it as the catalyst optimizer. Okay, that's the call of the chef, that he takes, that he create this plan of making that coffee, uh, and he makes that plan in the mind. Okay, to figure it out, because he has time limits also. So once he created that plan, okay, he will make sure that he has everything available, and he has to make it in a very limited time. He has to make it very fast. Okay, once he made that plan, okay, once he make all the 1 2 3 plans, he will check which will can be made, which I mean, how can it be made faster. Okay, so he'll select those plan where he can make this coffee, um, he can make the fast coffee. Okay, so that's what the physical plan is. So once the physical plan is done, he will uh, he serve the request then. Okay, so this is the example of the restaurant, in how the restaurant example um, fits with this park. Okay, I hope you like this video. Thank you.